Okay, this video is for 4-5. And what we're doing in 4-5 is we're solving. So 4-4 was all about factoring. Now we're going to factor to solve. So we talked about solving in chapter 3 when we were doing quadratics. So it says, recall from chapter 3, solutions to a polynomial equation. Everything we look at in 4-4 is going to be an equation. So it's going to have an equal sign. So solutions were also called roots, zeros, or y-intercepts. Hopefully that sounds familiar from chapter 3. This is what it looks like. Now in chapter 3, all of them were parabolas, right? The smiley face or the sad face. In chapter 4, so in chapter 3, we had only, at the most, we had 2 solutions. Something like that. In chapter 4, we might have 3 solutions like we have here, or we might have 4 solutions. We could even have 5. So these are the solutions. They're where your graph intersects the x-axis. So that's why, I said this wrong up here. This is x-intercepts. Big screw up. Sorry about that. That's why x-intercepts is the nice term. It's where my graph intersects the x-axis. But they'll also be called solutions or roots or zeros. So a problem might just say solve. You're finding these x-intercepts, finding these points. So in this section, we will use factoring to find solutions. The factors of this polynomial here are x plus 3, x plus 1, x minus 4. Take a look at these solutions. The solutions are -3, -1, and 4. Kind of think about how those relate to the factors. Hopefully that looks familiar from chapter 3. It says the solution is the x value. The y value will always be 0. So the equations must be set equal to 0. So the y value is always 0 because we're going over to an x value, but we're not going up and down at all. So this is 4, 0. This is -1, 0, -3, 0. It makes sense that the y value is always 0 if our point is always on the x-axis. So this is how it's going to look. We're going to factor to find the solutions. In chapter 3, you learned about this zero product property. I like to call it the ZPP. It basically says if you have 2 things multiplied together, so say I have a number and a number multiplied together, and my answer is 0. If my answer is 0, one of these numbers has to be 0, either the first one or the second. So it looks like this. If a times b equals 0, then either a must equal 0 or b must equal 0. That's the zero product property. We have to use it to solve these. We're going to assume they both equal 0. So these are equations that are already factored. So if an equation is already factored, and I have 2 things here multiplied together that equal 0, this is kind of like the a times b equals 0. If x times x plus 5 equals 0, then either x must equal 0 or x plus 5 must equal 0 by the zero product property. I just am going to assume they both equal 0, set them equal to 0, and solve for x. Well, this is already solved for x. X equals 0. To get x alone here, I need to subtract 5 from both sides. 5 minus 5 is 0. So I'm left with x equals -5. So the solution to this equation is there's a y-intercept at 0 and a y-intercept at -5. Those are my solutions. Let's look at, we'll look at this one quick. Again, 2 things multiplied together equal 0. One of them must equal 0. We're going to assume both of them equal 0. So I'm going to set both factors equal to 0 and solve for x. Remember, we're solving. When you're solving, your answer looks like x equals something. To get x alone here, I need to divide by 5. So 5 divided by 5, those 1 out, and x is by itself. 0 divided by 5 is 0. It's okay to have a 0 on the top. So one of my solutions is 0. To get x alone here, I have to undo subtraction. So I add 2 to both sides. Negative 2 and positive 2 make 0. So x equals 2. So those are my two solutions. I'm going to do this one next, D. We'll skip C. So in D, I have 3 things multiplied together that equal 0. So zero product property says one of them must equal 0, or perhaps all of them equal 0. So we're going to go with the all of them. Now 3 can never equal 0, right? 3 is 3, 0 is 0. So this one, when it's just a number, we're just going to ignore that. X plus 3 equals 0. I want x by itself. So I want to undo the plus 3 by minusing 3. So I end up with x equals negative 3. Here I have x minus 1, undo subtraction by adding the opposite. That makes 0. And over here, 0 plus 1 is 1. So those are my solutions. All right, so what happens when the equations are not factored, which is actually how most of your problems are going to look. So this says solve each equation. So again, you're finding what x is equal to. And it says you have to factor first. So these are not factored. We have to factor them. So when I look at this first one, I say, ooh, this looks like a greatest common factor problem. Looks like 2 and x are the common factor. So I'm going to divide each of these by 2x. 2 divided by 2 is 1. X to the third divided by x is x squared. Minus 4. The x is 1 out. Notice all of these are set equal to 0. That's how they need to be, like we said in the front. The equations have to be set equal to 0. So by 0 product property, 2 factors multiplied together equals 0. Then either 2x equals 0 or x squared minus 4 equals 0. Divide by 2. 2 divided by 2 is 1. So x equals 0 is one of my solutions. 0 divided by 2 is 0. This one, you have a couple options. You could do your x factoring method on this. Your b would be 0. Your a times c would be negative 4. The other method you learned in chapter 3, which you might have forgotten, is solving by square roots. If I add 4 to both sides, that's 0. So I get x squared equals 4. And to get rid of the second power, we did the square root of both sides. And we got x equals, remember whenever we're doing the square root of both sides, we put the plus or minus in. X equals plus or minus 2. If you did it the x method here, you'd get the same answer. Because you would say, oh, this is 2 times negative 2 is 4, negative 4, 2 plus negative 2 is 0. You would say these are the factors, and then you would set them both equal to 0 and solve. Add 2, x equals 2, minus 2, x equals negative 2. So either way, you get the same answer. There's 3 solutions for this one, negative 2, positive 2, or 0. This is also a way of writing positive 2 and negative 2. So hopefully you remember some of this plus or minus stuff from chapter 3. I went through that one quickly. Rewind and watch it again if you need to. Let's look at this one. This is very similar. Let's not look at that one. Let's look at this one. So what goes into 35 and 49? I'm thinking 7. And they also both have at least one x. So 35 divided by 7 is 5. X divided by x is 1. Minus 49 divided by 7 is 7. X squared divided by x is x. So here's my 2 factors. Let's set them both equal to 0. And solve for x. So divide by 7. 7 divided by 7 is 1. X equals 0. That's one of my solutions. This one's set up a little weird, but I know I'm trying to get x alone. So let's get rid of the 5 first. Subtract 5 from both sides. So that's 0, and I have negative 7x equals 0 plus negative 5 is negative 5. Now I have to undo multiplication by dividing both sides by negative 7. Negative 7 divided by 7, negative 7 is 1, so I have x equals, a negative divided by a negative is a positive, and then I'm just going to keep this as a fraction. X equals 5/7. You could put it in your calculator and turn it into a decimal, that's fine, but you don't need to do the extra step. You can just leave it as 5/7. Okay, let's do one more here. Let's do a trickier one. So this one I'm just going to say, oh, this you're going to factor using your x method. So you're going to have negative 15 and negative 2. You're going to get the two factors, set them equal to 0, and solve. I do want to point something out on this one. I'm not going to solve this one, but I want you to notice it's not equal to 0. So we have to make it equal to 0. So if I want a 0 on this side of the equal sign, I'm going to do minus 48, because 48 minus 48 is going to give me 0. But whatever I do to one side, I have to do to the other side. So I'm minusing 48 from both sides. Now over here, none of these are like terms. So I'm just going to write this out as x squared minus 2x minus 48. And then this I can factor. This is going to be negative 48 and negative 2 here. So you would factor that, set both factors equal to 0, and solve. This one is kind of a new idea that we did not look at that much when we did all the factoring in section 4.4. So I'm going to do one now, and I might do one in a separate video. The first thing I notice is there's a greatest common factor going on here, because 2 goes into all of these numbers and they all have an x. So I'm going to factor out a 2x first. So if I divide each of these terms by 2x, 2 divided by 2 is 1, x to the third divided by x to the 1 is x squared, minus 10 divided by 2 is 5, x squared divided by x is x, plus 8 divided by 2 is 4, x divided by x is 1. So now I have this. So I have two factors multiplied together, but if you notice, I'm going to cover up this 2x. If you notice this can be factored again. So I need to factor again. So we didn't do a lot of this in 4.4, but we need to now when we're solving. We have to get down to where we cannot factor anymore. And if you look at this, that's one that I can do x on. A times c is 4. B is negative 5. So multiplies to give me 4 is going to be 4 and 1. Adds to give me negative 5, I'm going to make both of them negative. Negative 4 plus negative 1 is negative 5. Negative 4 times negative 1 is positive 4. So this is what this is going to look like. I have to keep the 2x. That's the first factor I found. My other two factors are going to be x minus 4 and x minus 1. Now it's fully factored. So now I have 3 factors multiplied together that equals 0. I'm going to set them all equal to 0 and solve for x. So here I'm going to undo multiplication by dividing, and I get x equals 0. Good enough. Here, undo subtraction by adding 4 to both sides. X equals 4. Good. Another solution. Here, undo subtraction again, this time adding 1 to both sides. So x equals 1. So this has 3 solutions, which actually makes sense because an x to the third can and oftentimes will have 3 solutions. And there they are. But this is new. Just because you factor one time, you may not be done. You need to check what I like to call the leftovers and see if those can be factored again. Okay, that's it for this video.